Okay, so in the previous video we ran through the first set of requirements. We implemented a class calc that performs addition, and our addition accepts multiple arguments. These are the two tests we wrote. Actually, we wrote 3 tests, but after writing the last one, we decided these tests, well, I decided the last test was testing the case tested by the second one. So the test 3 at the 3 numbers. So I removed it. And these are enough. If I run pytest-svv, I get these nice lines with a green reassuring past. And before we go on with the requirements, I want to show you the usage invocation help page for pytest. So pytest, as I said, has a very nice documentation. It's very good. Go and read it, especially when it comes to fixtures. We will talk later about them. However, in this page you have a description of some of the command lines, well, all the command lines options that you can use. You can see here there's -k. We discussed it last time. I wrote a very brief blog post on the Digital Cat Online that sort of recaps the most important things that you can do with pytest, how to run single tests, how to skip tests, and so on. So go and read this as well. Okay, let's go on with the requirements. So as we implemented addition, we might as well implement subtraction. It's more or less the same thing. So here we go. What we have to do is to write the test first of all, always. So def test sum 2 numbers. There is no real point in trying to subtract multiple numbers. Yes, you can subtract from the first one all the second, the third one, the fourth one, and so on. But yeah, I don't believe this is a very good API. So in general, so the requirements don't ask you to subtract multiple arguments. So this is only for 2 numbers. And yeah, this is basically the same thing we did before. Result equals c dot, well, we have to decide what to do. Well, for coherence, I would say sub, as I could add the function that sums numbers. So yeah, I don't know, 10 and 3. And then I assert that result equal, well, 7. This is enough for me. I can go and run pytest, and it fails. As I said, as I told you in the first video, this is good. This is what we aim for. Generally speaking, we want to have a failing test. So here the error is attribute error calc object. There's no attribute sum. Yes. Obviously, so let's go to the calc, and now on a second thought, it's up to you. So I don't want to show you how to do it. It's easy enough. I suggest you stop the video, you implement the code, and then you check my solution. So I believe you stop the video, you did something, you probably have some code that passes the test. My solution is def sub self a and b return a minus b. Okay, so I have to do a minus b because here I did 10 minus 3. So as you see, through the test, you decide the API. To be honest, the API should be, as I said in the previous video, it should be designed before. But you test calls for an API if you want. So this is my, did I save? Yes, this is my solution. It works. And maybe you notice that I didn't go through all the steps like we did before. So I didn't create def sub self to have a test telling me you are not passing A and B, then return 7. This is because, well, for two reasons. First of all, this is a workshop we have to get somewhere, so I don't want to be too pedantic. But generally speaking, as you mature, as you grow up as a tester, you can skip some parts of this, because you know after all that the test wants two arguments, so you want to pass them. There is another thing I want to say. Actually, this works if I just return 7, as we saw in the previous video. We don't have here any test that checks that return 7 is not enough. Again, this is a simple example. It's not a complex. It's not a complex object. It's not a complete API. Blah blah blah. So, in a real case, you should have some other test here that tests that function, that tests corner cases, and so on. For example, well, since we are at it, let's say I return 7 here, and then everything passes, right? So, what about corner cases? I didn't plan for this, but now that I think about it, it's important to discuss corner cases. We didn't do any corner case here in add. So what are corner cases? Corner cases, generally speaking, are the difficult cases. So when you add two numbers and you say, okay, I add 4 and 5. 4 and 5 are two standard numbers, two very good numbers. They are small enough, and they are positive numbers. So what about adding negative numbers? What about adding numbers with 0? So I can show you this with the sub. Please keep in mind that we should do it for add as well. We are doing it for sub only. This is a demonstration. So sub two numbers, two negative numbers. Okay, this is what I want to do, and to spare some time, save some time. Sub -10 minus, so to do something different. So -10 minus -5 gives -5. I don't really like the fact that this is like this, because it's another corner cases. So let's say -8. Yeah, cool. So now I can test it, and it doesn't work because, well, we know it, right? That return 7 is not enough. So now we have our second test that checks that everything is in place. It passes. We didn't test all the corner cases. I want to show you all the tests that I could write for this simple function or method sub, just to show you that generally speaking you have a great amount of tests for a small amount of methods or classes. Because tests have to take into account, well, yes, different cases. So, for example, another thing could be adding, subtracting negative numbers, negative and positive numbers. So, for example, subtracting 10 and 2, and this should be 10 minus 2 gives 12. Okay, it works. Okay, cool. Maybe too many things. First of all, I hope you got the point. So I might write another test that says -2 and 10 to check that everything works if I swap these two. So if the negative number is in the first place and the positive number is in the second place, then I should check with 0 to see that 0 minus 4 gives -4, and that 4 minus 0 gives again 4. Many tests. So I'm not gonna write all of them now, but yes, keep in mind that you should aim for those corner cases. And generally speaking, you have one or a small amount of standard cases, while you have a great amount of corner cases. So when your numbers, when your quantities, when they are extreme, and so when your attributes, if for example you have optional attributes, so you have to test if the attribute is there, if the attribute is not there, if the attribute is there with an invalid value, blah blah blah. A word about the last test, actually about the last two tests, because I didn't comment, I didn't say anything about the fact that they passed. And I told you so many times I want my test to fail. So in this case, let's consider this last test. I add this new condition, and I am already confident that my function works. I am testing something more. But I told you, you have to ask yourself, is it useful? So since the test already passes, let's say, for example, I hope I'm not confusing you. If I say here, def test two numbers again, and do, 12 minus 1 gives 11. Yeah, it passes, test two numbers passed, test two numbers again passed. But at that point I should ask myself, okay, it already passes. Is it useful? And actually, if you consider this test, it is testing exactly the same situation, exactly the same condition tested by this one. So it's not a different case. These are two positive numbers. Yeah, they are different, but they are the same. So this test is useless. And generally speaking, we are against useless tests because these are 1, 2, 3, 4 lines of code that I have to maintain. For example, if I want to change the name of sub to something different, I have to go and replace it here, replace it here, replace it here, replace it here. I know you can replace, with an editor, whatever you want, but this is maintenance. So remember that tests have to be maintained. And you don't want to write, you want to write the right amount of tests. And unfortunately, I cannot tell you what the right amount is. You have to learn it. In this case, as I said, this is not good, so I'm gonna remove it. As for these two, they passed. They passed immediately without failing. But there is a reason for these tests. So this test is testing a corner case, as we said before. So I consider the fact that it passes, and I decide to keep it because it represents an important corner case. Yes, an important case to test. Just to say that if someone goes and in the future says who goes here and changes this function, doing something extremely complex, for example, there is machine learning subtraction, so creates something incredible here to subtract these two numbers. But the new algorithm works only with positive numbers. At that point, this test will show that the new code is not good enough. So this is why I want to keep the test. I hope this is clear enough. As I said, I'm not going to write all the tests that, for example, that include 0 and other corner cases. I want to move on now with the requirements. You are free, however, to go and add everything. Try to add the tests and try to decide if the new tests are useful or not. The next requirement is multiplication. And as happened for addition, we will have to implement multiplication with multiple arguments. But so for now, for the time being, we can go for two numbers as we did again for addition. So my test is test multiply two numbers. Again, I instantiate object res equals c dot mul sensible name 6 4, just because I know how to multiply them, which is 24. Sorry, obviously this is res equal. Cool. Can run it and it fails. I didn't save. Okay, it fails with name res is not defined because I didn't save the previous thing. So yes, here we are. So it fails with what we were expecting. So calc object, there's no attribute mul. Go and implement. Stop the video, implement it, and then when you come back, I can show you my solution. So if you stop the video and you implemented the solution, you came up with something that hopefully passes the test. This is my solution. Easy enough. I know it might sound very, very trivial. Again, bear with me because we are learning TDD. We are not learning Python here. So I know you know how to multiply numbers. Let me check that my solution works. Yes, I'm happy with it. So let's move on and consider multiplication with multiple arguments. We might go for 3 arguments as we did with addition, but I hope you understood the process. So I will go directly with test multiply many numbers. So def test multiply many numbers. Again, as happened for the addition, we cannot really test an infinite number of arguments. So we have to go for something simpler. But as I said for the addition, having like a test that checks we can multiply 2 numbers and a test that checks we can multiply, let's say 10 numbers, it's somehow enough for me to say, okay, I guess these two cases show me it works always. So here in test multiply many numbers, I want to do something similar to what I did for addition. I create a range 1 to 10. I don't create a range 10 because this includes 0, and if I multiply everything with a 0 inside, I get 0. So I assert that calc multiply all these numbers gives me magic. Look, I did it in my head. Yeah. This is what you get when you multiply all the numbers 1 times 2 times 3 times 4, so on. Okay, this is my test. I can check that it fails. Yes, we know multiply takes 3 positional arguments, so these ones, and I got 10. So, okay, again, it's up to you. How do you solve this? Because there is no built-in mul. So that we had the sum built-in function in this one, but we don't have the built-in multiplication. So stop the video. I strongly advise stop the video and try to solve it. I know it sounds trivial, but if you don't do it, you will never learn. So stop it and come back. And my solution is, I don't know what my solution is. Let me think. So I have to multiply multiply many numbers. So first of all, I definitely want to accept as many arguments as the user passes. Then I will go for a very simple solution, I believe. The most trivial solution that pops in my head is a for loop. So, looping over this tuple and multiply all the numbers. So I will start with a result which is 1. And then say for I in S, which is a tuple, result equal result times I. Yes. And then return result. Well, I believe this is correct, but I have to check it. Let's do it. Yes, it passes. Cool. So, as I told you before, probably too many times, but yeah, sorry, bear with me. If your tests pass, your code is perfect. This is from a testing point of view. So now I am wearing a hat with T on top of it, so like tester. And I am happy with this. I don't want to change anything because all my tests pass. When I change my hat and I put on the developer or the optimizer or the OCD developer, if you want, I might come here and say, this is not good enough. I don't like it. I don't like a 4. It's too slow, whatever. In this case, I'm definitely not concerned with this code, But I show you before this. You can go back and change it to match, for example, style to match to give better performances. Your tests are the safeguard. So your tests keep testing everything and testing that your sub functions, subtracts all the corner cases, So it's very important to have tests because they are your memory, if you want. It's the historical memory of your code. In this case, I just want to show you a very simple refactoring. The thing is, there is a better way to do this if you come from a functional background, like for example Scala, or Clojure or something. You already know that I'm gonna use reduce, and so if I can from functools import reduce, and I might here just return. So reduce, and here I need a function that runs on two arguments. So how do you spell lambda? X and y. X times y. Yes, on S. I believe this is correct, but there is only one way to know it for sure. Yes. Okay, so I didn't want to show off, this is just a reduce, but I wanted to show you an example of refactoring. I came here, I come from Clojure, for example, and I say, no, you have to go functional all the way. What is this object-oriented that you are using? So I want to use reduce, I want to use lambdas, and then functions, whatever, anonymous functions. And so I do it, and I check it. I check it in my tests. So everything is correct again. And I can go home and believe, I did a good job. I optimized my code. I made it more beautiful. And the test still passed, so the output is the same. But in this case, I want to go back to my previous solution. Yes, this one. Cool. Just to show you that I don't really care about smart Python codes, Python solutions now, because this is the TDD workshop. You might have noticed one thing before we move on with the requirements, which is that here I wrote the test in a very compact way. This is perfectly fine because, the test is Python code. So you might write this, which is sort of very verbose way of performing that calculation, or you can do something a bit more compact here. It's fine. PyTest understands whatever you write here and runs your code and checks that it works. So yes, write the test as you want. I sometimes switch between the two styles. It might slip into the workshop here. So yeah, just bear in mind this is exactly the same thing as you saw here. And the next requirement is division. As you know, division will have many other requirements later, but for the time being, we have to divide two numbers. So again, my test is def test divide two numbers, and I assert. Yeah, again, I go for the short version now that I introduced it. Okay, let's go for something trivial and probably not completely correct, but yeah, this thing here, just to show you, some that your tests are not your tests might be not smart enough. Yes. So it's up to you to write proper tests. And why do I say this test is not proper? Because 22 divided by 2 is a very nice case. It's very easy to do it. Well, not only easy to do it for a human, but it's a nice number. It's not a fraction, it's not 22 divided by 3. In particular, it returns an integer. And this is, so we are basically not testing a very generic case. We are already testing a corner case. Fortunately, we have later something that checks floats, so I'm not that worried now, and I'll keep it. So let's see what pytest says about it. Usual stuff. Now you will pause the video, you will implement your code, and then come back. And if you did it, you will have something similar to this: self A and B. And what did you return? So did you return A/B? I want to be honest. I never remember which is which. So is it slash or double slash? I don't remember. But I'm not that concerned because I have my tests, right? So as I said, if the test passes, the code is correct, well, we might go for it in this case and see if it passes, and it does. Amazing. So this double slash is fine for me so far. I'm pretty sure this is an integer division. So this works because I am testing a corner case. If I was already testing like a proper general case, this might fail. Yes. Okay. So I'm implementing here an integer division, but this is the test we wrote, and this is what I'm gonna keep for now because I have another requirement here that says division shall return a float. And this is exactly what I'm gonna test now. So divide returns floats. And I might as well do exactly what I did before. So 11 divided by 2 is 5.5. Okay. On my test. And now, yes, I have divide two numbers works. Divide returns floats doesn't. So yes, we know what the error is because I already spoiled it. I said, there's a double slash. But my point is, this test is showing you what is wrong in your code. You obviously have to think now, what did I do to make the test fail? But you have an alarm that your code is not enough for all the cases. So I will go now and I will go now to my code and remove this slash. And it passes, and for the next 5 minutes I will remember that one single slash is a float division in Python. The next requirement is that division by 0 shall return the string inf. I already said it before, please don't take this as an example of a good API. It's terrible. We have a method that returns floats in some cases and strings in others. This is bad, so don't do it. I want to do it just to show you how to deal with exceptions in the code. So first of all, I want to write a test for this, which is def test divide by 0 returns inf. Okay. So what I do is to, well, simply assert that calc div, 50 is inf. Okay, this is the string. Now pause the video, implement the code, and come back. My solution is a very simple if. So if not b, return inf. Let's see if this is good enough. Well, sorry, we didn't check. I didn't check it was failing. Sorry. So let's first check. It fails, yes. And it fails with zero division error. So Python tells you are doing something very wrong, mathematically speaking. So yes, this is my solution, and now the test passes. Since Python returns an exception, you might go for a try except, and this is another example of the refactoring I was talking about before. So I might say try return a divided by b except this zero division error, return inf. This is another version of the same code. It passes. We might argue, it's more Pythonic. It's better to try with if, to go with if, to try and accept. It's up to you. Again, I don't want to face these issues now. I'm happy because my test passes. So for me, the code is good enough. Cool. So far, so good. So we have 3, 6, 9, 10 tests that are checking our code. As you can see, as I said before, we have 10 tests and 4 functions. And actually, we should have more tests for addition, for multiplication. So, multiply by 0, add with 0, add negative numbers, blah, blah, blah. So we might easily have 30 tests or more for just 4 methods. Again, you will usually have more tests than, more tests than code. Sounds good. Yes. So this is what happens a lot of times, because for the same function you have multiple tests for the corner cases. The next requirement is multiplication by 0 must raise a value error exception. Again, as I said, this is mathematically multiplied by 0 is perfectly fine. In this particular case, I want you to raise a value error because I want you to learn something connected with pytests. So the problem here is that we want the test, we want the code to fail, not to succeed. Let me show you what I mean. So let's try to write the test. So def test multiply by 0 raises exception. This is the name of my test. And what shall I do? So I should do something and assert that I get an exception. But if I get an exception, the test fails. So I hope you see the points. Here you have to sort of neutralize the assertion, not only to neutralize it, you want to verify that there is an exception, and if there is an exception, that specific exception, you want pytest to say, yes, I'm happy, good, so passed. And you cannot know how to do it, but I want to show you. First of all, you want to import pytest, import pytest. PyTest is a framework that runs your tests, but it's also a library, so you can import it. And here you want to use a context manager, more on this in a second, that says raises value error. And inside the context manager, you want to run your test. So calc.multiply 3 and 0. Okay, so this is the test. Let's verify it fails. Yes, okay, it fails, and it fails in a specific way. So it tells you in capital letters, did not raise class value error. So what pytest is telling me is that calc multiply 3 0 works. It works. It does not raise value error, and I know it because this small loop here gives me 0, because 3 times 0 gives 0. So yes, the test fails because the code didn't fail. Okay, I hope it makes sense. A word about the context manager. If you're not used to it, go and Google for it. Context managers in Python. Long story short, what this with does is to say whatever you write here inside the with runs in Python with a sort of different set of rules. It's like if you have a zero gravity bubble, you have on the surface of the Earth, the gravity is 9.8, but inside your bubble there is no gravity. So you have a sort of a bubble where there are different rules, right? Like sort of magic. And what are these different rules? It depends on the context manager, which is this part here. And in this case, the pytest raises says that whatever code runs here has to raise value error. Otherwise, there is an assertion error, or there is a failed test. So it sort of reverses the way it works. Usually you have code that works and should not fail. In this case, the code has to fail. So yes, this is the test. The problem is multiply by 0 doesn't raise value error. Pause the video, go and implement your solution, and come back. My solution is similar to the previous one. So I have multiply here. I have to basically say if there is a 0 inside this tuple, raise the error. So this is exactly what I'm gonna do. If 0 in S, then raise value error. Okay, let's see if pytest is happy about it. Yes, it is. So as far as I'm concerned now, this code is correct. You might have a different solution. This is true for all the tests I wrote. Your code might be completely different. I believe probably, well, the subtraction will not be that different, but in particular multiplication might be different. This one, we already discussed that it might be implemented with an if, like we did for multiplication. So yeah, okay. So now all my tests are passing here, and it's time to move on with the requirements. So let me review what we did. The set of requirements we had, and what we did. So the goal is to write a class calc, done, that performs calculations, addition, done, subtraction, done, multiplication and division, done. Addition and multiplication shall accept multiple arguments, we tested it. Division shall return a float, done, and division by 0 shall return the string inf, done. Multiplication by 0 must raise a value error exception, and that is done as well. So now the next requirement is a complex requirement. So this video will end here, and I will go on in the following one. Just a word about it. So this is the average function. In this case, I will go and try to dig up all the corner cases, because I'm interested to show you a proper session of TDD. So trying to test everything of that function. But more on this in the next video.